Hi everyone, welcome to this last video over IPv6 addressing formats and rules summary. This is a brief resume over this topic. What did I learn in this module? The first is IPv4 issues. The depletion of IPv4 address space has been the motivating factor for moving to IPv6. IPv6 has a large 128-bit address space, providing 340 undecillion possible addresses. When the IATA began its development as successor to IPv4, it used this opportunity to fix the limitation of IPv4 and include enchasement. One example is ICMP version 6, Internet Control Message Protocol, which include addresses resolution and address auto-configuration not found in ICMP version 4. Both IPv4 and IPv6 coexist, and the transition to only IPv6 will take several years. The IATF has created various protocols and tools to help network administrators migrate their networks to IPv6. The migration techniques can be divided into three categories: dual stack, tunneling, and translation. Dual stack devices run both IPv4 and IPv6 protocol stacks simultaneously. Tunneling is a method of transporting an IPv6 packet over an IPv4 network. The IPv6 packet is encapsulated inside an IPv4 packet, similar to other types of data. NAT64 allows IPv6-enabled devices to communicate with IPv4-enabled devices using a translation technique similar to NAT for IPv4. An IPv6 packet is translated to an IPv4 packet, and an IPv4 packet is translated to an IPv6 packet. And the other topic is IPv6 addressing. IPv6 addresses are 128 bits in length and write as a string of hexadecimal values. Every 4 bits is represented by a single hexadecimal digit, for a total of 32 hexadecimal values. IPv6 addresses are not case sensitive and can be written in either lowercase or uppercase. In IPv6, a hextet that refers to a segment of 16 bits, or 4 hexadecimal values. HX is a single hextet, which is 16 bits or 4 hexadecimal digits. Preferred format means that you write IPv6 address using all 32 hexadecimal digits. Here is one example. Okay, this is the example. There are two rules that help to reduce the number of digits needed to represent an IPv6 address. The first, Rule 1, omit leading zeros. You can only omit leading zeros, not trailing zeros. 01AB can be represented as 1AB. 09F0 can be represented as 9F0. And the rule 2, double colon. A double colon is this, can replace any single, contiguous string of one or more 16-bit hextet consisting of all zeros. For example, this address could be represented as this address. The double colon is used in place of the 3 all 0 hextet. The double colon can only be used once within an address, otherwise there would be more than one possible resulting address. If an address has more than one continuous string of all zeros sextet, best practice is to use the double colon, one the longest string. If their strings are equal, the first string should use the double colon. And Webster reflection question. Just when I was starting to get the hang of IPv4 address, I learned about IPv6 addresses. but since it looks like most networks use both types of address, I'm glad that I know a bit about each type. I guess it's like cars on the road. Some are old, but they are still run. New cars have many more features and options than the older cars, and both old and new cars are all driving on the same road. What is one obvious advantage to using IPv6 address instead of using IPv4 address? IPv6 addressing formats and rules quiz. The first quiz: what is the advantage of using IPv6? More addresses for networks and hosts, faster connectivity, higher bandwidth, more frequencies is more addresses. Question 2. What was the reason for the creation and implementation of IPv6? To make reading, to relieve IPv4, to provide more addresses space in the Ethernet names registry, to allow not supporting the private addressing now. Question 3. Which letter represented the hexadecimal values of the decimal number 50? 50 F. Question 4. A PC is configured with both an IPv4 and IPv6 address on the same network adapter. What IPv4 and IPv6 coexist strategy is implemented on the PC? Tunneling, NAT64, or dual stack. Question 5. What are two methods that can be used to shorten the IPv6 address notation? Use of double colon to represent a string of all zeros exted. Omit all leading zeros from all x's in the address. Question 6. Which network migration technique encapsulates IPv6 packets inside IPv4 packet to carry them over IPv4 network infrastructure? That is tunneling or translation, sorry. And question 7. What does a double colon represented in an IPv6 address notation? A continuous strings or one or more extents that contain only zeros. Question 8. IPv6 increases the IP address size from 32 bits to how many bits? Uh, IPv6 increases the IP address size from 32 bits to how many bits? I don't remember how much, how many, sorry, but I say 128. Yes, it's 128. Question 9. Which technology enables devices in IPv6 only network to communicate with devices in IPv4 only network? Not 64. Which technology enables devices in IPv6 only network to communicate with devices in IPv4? Tunneling. I don't know. Translation. Which technology enables devices in IPv6 only network to communicate with devices in IPv4 only network? Not 64. Network address translation 64. Question 10. Which IPv6 address notation is valid? And question 11. Which two statements are correct about IPv4 and IPv6 address? Choice 2. IPv6 addresses are represented by hexadecimal numbers. IPv4 addresses are represented by hexadecimal numbers. IPv6 addresses are 32 bits in length. IPv4 addresses, okay, I think is this. Okay, okay, my bad is DG. Okay, is encapsulation. No, tunneling. Okay, and reset. What is an advantage of using IPv6 small addresses for networks and hosts? What was the reason for the creation of IPv6 implementation to allow NAT support for private addressing to make reading 32 bits address easier to relieve IPv4 address installation? Question 3. This F stack. What are two methods? Okay, okay. Which networking migration techniques encapsulate tunneling? Continuous streams, one more. IPv6. Okay, not is this. And question 11. IPv6 addresses are represented by hexadecimal numbers, and IPv6 addresses are 64 bits in length. Okay. Okay. This is all for this. See you in the next module. Module 11, Dynamic Addressing with DHCP. Bye.